Well, here's a glimpse of how it looks. Now, try to picture, if you will, something sticking out of here, like that. So, you can just spin it like that, or you could do it like this. This is all going to be tied up, so even turning this, you'll still be able to make minute adjustments by hand. So everything's going according to plan. This is what it looks like with the aluminum one that I'm making. Again, I'm going to use 3D printed first, and then once I have this machine up and running, I'll start milling this stuff out as one of the first projects for this machine. Now, another project, I've got this mounted now with the couplings on, so these are good to go. I'm a little concerned about the wobble on this one. Let me show you what I'm talking about. If I use the rapid feed, see that moving up and down? I'm not quite sure why it's doing that. I was pretty accurate, unless it is this rigid coupling causing the whole thing to go a little wonky on me. Either way, it's temporary, but I'm hoping when I get the new coupling, the Lovejoy, it fixes it. I made another one of these, so I've got two now. So these are ready to go when the mill's ready to go. But yeah, that's where we're at. Now, manual and CNC. I'm just waiting on a power supply, 48 volt power supply. As soon as that comes in, we should be good to go. Alright guys, getting excited here. Catch you later. Hey everybody. Well, I ran into a snafu, whatever you want to call it. I got the stepper motors running and running good. Now here's the problem. They run for about 5 seconds and then shut down. So in my CNC video, that was a very basic, to the point video of what you need to get started. But like I said, there's a lot more to it than just that. So let me explain to you what's happening and where I went a little bit wrong with what I did. Stay tuned and we'll get into it. These motors are NEMA 23 570 ounce torque motors. Each phase is rated for 5 amps, 2-phase motors. So technically you need 10 amps for each phase. Now voltage is a little different. You can pretty much run whatever voltage you want, 12 volt, 24, 36. I mean, I wouldn't overdo it. Definitely go by what the manufacturer states. The manufacturer for these state 48 volts, but you don't necessarily need that sometimes, whereas the drivers that I'm using are good for, let's say, 40 volts. Hang on, let me see. volts. So let's say you do a 36 volt power supply and you bump it up to like 39 volts, because usually they're adjustable, and it'll work good. Problem is, depending on how much current your motor's drawing, you're pushing these to the limit on the smaller ones. Whoops. These are good for 3.5 to 4 amps max. Now these motors are rated for 5. Now that doesn't mean you got to push 5 amps through them. But even if you max out this driver, max out the voltage and max out the amperage, well, what do you think is going to happen? It's going to overheat. So this is a $6 driver. The next one up from this are these here. These are DM542s. I don't even know if this has a number on it. No, I believe these are TB6600s. These are standard, very like low-end drivers, bottom of the line. These are the next ones up. You can see the size difference. There's DM542, and I want to say there's a DM556, another one up from this. Now, where I went wrong was in the box that I built, I used 4 of these drivers. And to be honest, I did that because of space. I was very limited as to what kind of room I had. In fact, I couldn't even put the power supply in the box. I had to do it on the outside. But unfortunately, it didn't work. So, that being said, this is the box for my lathe. I've been dismantling it, taking it apart. It had the bigger stepper drivers in it, and these were driving smaller motors. So what I'm going to do is I'm going to swap this box out for my mill and this box out for my lathe. I'm going to switch them. That way I can try the bigger drivers. And I'm still not 100% sure the 542s are going to drive the big NEMA 23s. The problem is these 23s are basically borderline 34s. This has just as much torque as a small NEMA 34. So you're really getting on the border of needing another upgrade on the driver, depending on the size of the motor you're talking about and the torque. I mean, there's other issues like resistance of the coil and etc., but no way I'm going to get into that now. So anyway, make a long story short, I'm going to swap out my boxes for my lathe and my mill, and I'm going to switch them up a little bit because I can't get this to run very long on a small driver. So that's where I'm at now. Alright guys, just giving you the heads up. Tuesday, I'm getting in my 48 volt power supply, which is going to be, for these bad boys, 50 volts. So 48 volts, and these I'm hoping will be enough. If it's not, well, then I'm going to have to go with the next one up. But is what it is. Alright guys, catch you later. Alright, I got her working. That's the x-axis going back and forth, and that's the y. Nice and smooth, no problems. I did have to make some modifications. I had to go with the larger stepper controllers and a larger power supply. I'll explain that a little later. That's the circle we just made. I'll move this over so we can do it again. So basically, focus, zero, everything's zeroed, rewound, we'll hit cycle start. It takes a little bit of time because I don't have the feed rate correct, but here it goes. Okay, and done. So let's back this bad boy off and see what we got. You could tell right there and there we got some backlash issues. So we just have to adjust that in the program. But hey, we just did a circle on our manual milling machine, so I'd say we're doing pretty darn good. Alright guys, that's it for this weekend. Next weekend there'll be some more stuff to talk about. Alright, catch you later.